Welcome back, students. Let's do another topic of motion chapter, that is uniform circular motion. Now, when we think about uniform circular motion, we can imagine a wheel moving, okay, or maybe Earth moving around the sun, or maybe moon moving around Earth. So those motion are in uniform circular motion. Now, the speed of the wheel or the motion of the wheel could change, right, as you accelerate. But the motion of the sun, or you can say not sun, the earth or the moon, could be considered as a uniform circular motion. Okay. So what exactly, is a circular motion? When anything which is moving in a circular path. Okay, just a second. Let me take the annotation pen. Okay. Yeah. So anything which is moving in a circular path. Okay, with the same speed in a particular given time would be uniform circular motion. That means the speed remains constant. It means, for example, if something starts from point A and moves this circular, in circle and come back to A with, just a second, sorry. Yeah, comes back to A in, 10 seconds only. And again, it does the same thing, comes back to, in second step also in 10 seconds only. Then again, third time also it did the same thing. So it is in uniform circular motion. Okay. For example, a rider on a Ferris wheel moving at a very constant or steady pace, sorry. And our earth gracefully revolving around the sun, which I have already told, and the joyful spin of a merry-go-round at a playground, which you play, right? So that also, like, something like this is there, and you sit here, right? And somebody else sits here. And if it is moving in a constant motion, then you can say it is in uniform circular motion. Now, how we can do numericals on the basis of that, how we can, figure out the velocity and everything else in this, that we have to study, because the case is a little bit different. It is not in a straight line, okay? So, here, the constant speed, if we talk about, while the magnitude of velocity remains constant, the direction of motion constantly changes. Now, hear me out. Try to understand this. So, at every point of a circle, if I'm moving, you will see I'm constantly changing the direction at every point. Are you able to understand? Like, for example, I am here, I am moving in this direction. But if I pick out here, this exactly, different, just the next point, I will be moving in this direction. If I pick out this point, compare these two. In this point, I was moving in this direction. At this point, I'm moving in this direction, or maybe let's say this direction, right? So at every point of a circle, you can say the direction is changing, right? And velocity has both the things. It has magnitude and it has direction also. So direction here in a circular motion keeps on changing. Now, let's talk about the changing velocity direction. The velocity vector is always tangent to the circular path at any given point, indicates the instantaneous direction of motion. What do we mean by that? Again, the same thing I told. So velocity is something, speed with direction, right? Nothing else. Magnitude with direction. So at every tangent, you will see there is a change, instant change in the direction of motion. And that is changing velocity direction. That the direction of the velocity is changing. Now, centripetal acceleration. What do we mean by that? An object in uniform circular motion experiences acceleration always directed towards the center of the circle, essential for maintaining the circular path. Now, suppose if something is moving in uniform circular motion, right? So it will be always attracted, you can say, or accelerated, you can say, towards, the acceleration will be to stay towards the circle at a particular distance or a particular radius, right? Radius will remain the same if it is a circle, right? So at every, distance, you will see that there is always, acceleration directed towards the center of the circle. So acceleration will be also in a particular, you can say, direction that is towards the center, and that is centripetal acceleration. If there will be centrifugal acceleration, the thing will go out of the, circular motion and leave the path of the circle. Okay, leave the circular path basically. So this is all we mean by it. Again, this can be a very, in-depth topic. So don't worry, we'll take it, we'll cover it as much as we can right now, and then rest in the regular classes. Okay. So the term radius, it has a symbol of R. So we have to just know some terminologies before we move ahead. Period. What exactly period? Radius, right? The distance from the center of the circle to the circumference at any point, right? So distance from the center of the circular part to the object. If your object is standing here, so this will be the R or radius. If it is standing here, it will be R. Okay. Now period. Period is denoted by T. Okay. Period is the time taken for one complete revolution around the circular path. That means if you started from point A again, so how much time have you taken to reach to A again? Is it 1 second? Is your period is 1 second? Is your period is, let's say, 10 seconds? How much is it? Okay, so that is period. Frequency is nothing but 1 by T. Okay, what do I mean by 1 by T? That the number of complete revolutions performed per second. Okay, now in 1 second, how many revolutions have you made? That is frequency. For example, here in 1 second, let's say you are taking 10 revolutions. You're going very fast. Okay, 10 revolutions. So here you can see the time is basically 1 second, right? But your frequency is 10. Okay, so frequency is 10 revolution. And if you want to calculate the period, it will be 1 by 10. Sorry, yeah, okay, right? So that is it. Okay, just let me take. Right. Now coming to speed. So speed is equals to V again. Speed or distance covered by the object per unit time would be V, that we know. Speed or velocity you can say, but again it's changing, the direction is changing, right? Okay. Now, the centripetal acceleration, how will you calculate a centripetal acceleration? So centripetal acceleration is the acceleration that is continuously pulling the object towards the center of the circle. This we discussed, right? The acceleration which keeps the object towards the center and not pushing it out like this. Instead, keeping it towards the center like this, always. Okay. Now, preventing it from flying off in a straight line. Okay, without it or uniform, just a second. Yeah, without it or uniform circular motion would not be possible. Okay, so here the formula for calculating the centripetal acceleration would be AC, if a centripetal acceleration. So we do not get confused with the normal acceleration. Okay, V square, what is V? V is our speed again. Okay, the speed of the object and upon R. That means the distance or the radius from the center. Okay. So its direction is always radially inward. That means moving inwards. This I have already told you. Okay. Perpendicular to the tangential velocity. This is perpendicular, right? Every time you will check, it is perpendicular only. So this is the formula. Using this formula, we can solve a lot of, problems. But again, since there is centripetal, 1 second, let me just, sorry. Okay. Just let me pick out the pen. Okay. Yeah, centripetal force. So once, there is a force, there is attraction, right, between the object and towards the center. So obviously there is a force which is acting to keep it towards the center, right? And to calculate or what will be the force will be basically centripetal force, which is acting for a uniform motion, would be F is equals to MA, and A would be acceleration, because you know the formula of force, right? So it is MA, and acceleration here is centripetal acceleration. So F is equals to MA. Now, in case if you do not know A, you can again, calculate your A, right? Or if you do not, AC. So it will be M and V square plus V square upon R. Okay. Fine. So this is how you can calculate it. Okay, just a second. Yeah. So m here is the mass of the object and acceleration a. C is the centripetal acceleration here. Okay, and you have just done nothing, but you have put the values of a here. Okay, that I just, again, I'll tell you. Basically, centripetal force is equals to m acceleration a, centripetal acceleration. Okay, and here you can put the value of a, which v square upon r. So you can get your centripetal acceleration, even though centripetal force, even though you don't have direct value of centripetal acceleration. Correct? So this is it. So suppose if you have taken a rope, you have attached to a you can say stone, and if you're moving it like this, right? If you're making a uniform circular motion, and if somehow you get to know the mass and the acceleration, you will be able to calculate the force which is being applied to keep that stone towards the center in your hand itself, and it is not moving away from your hand. Okay, so this is it. And then coming to the velocity, frequency, and also the radius. So what happens is, basically this is the speed, right? The speed of the object is equals to the circumference, you can see, right? So the speed of the object obviously will be how much it has taken from here to here. This is nothing but circumference, right? 2 pi r. Upon how much time it has taken to complete that one revolution, right? So t. So that will be v is equals to 2 pi r upon t. It is a little bit different from the normal cases because the distance here is 2 pi r, distance covered, right? So whatever is the radius, you can put it here. Pi, you can put 22 by 7 or 3.14, whatever value will be, easy to calculate with. You can put how much time it has taken and you will get your, speed, how much speed you are moving something with in a circular motion. Okay, if you do not have t, what you can do is, so t is nothing, period is nothing but 1 by f you can do. Okay, right? So sorry, f is nothing but, just forget this, f is nothing but 1 by t, right? So what you can do is, you can put 2 pi r f instead of 1 by t, because this is nothing but 2 pi r, t is nothing but 2. Okay, let me write it in a better way. Okay, yeah, so 2 pi r is nothing but 2 pi r upon 1 into 1 by t, right? This is it, no? So that's why here, instead of this, you can simply write f also, frequency. And if you have given with frequency and not the period, you can put the frequency and calculate your final speed. Okay, so this is how it's done, right? Okay, so again, try answering these questions. Sorry, let me go back. Okay, yeah, so the question 1 is, in uniform circular motion, the acceleration is it tangential, is it radial inward, or is it 0? So again, it can be a little bit troublesome for you, but I am sure you'll be able to solve it. The second question is, what is the correct formula for centripetal force? So is it F is equals to ma? This is acceleration, centripetal acceleration. Okay, let me just put it here like this, AC. If you are confused, just write this. Okay, F is equals to mv, or F is equals to v square upon r. Okay, also last question is, if the period of revolution is 10 seconds, what is the frequency? Is it 0.1 hertz, is it 0.2 hertz, or is it 1 hertz? Okay, so try answering this, and this one you can, I think, try solving, and answering, right? Okay, so with this, we are done with another chapter. Thank you so much for joining. You can check out my Urban Pro profile for, more information and more such videos. Okay, thank you. Take care. Bye-bye.